Welcome to the lesson Motion and Speed. In this lesson, you'll learn the science behind the concepts of motion and speed. The vocabulary words for this lesson are motion, speed, position, reference point, velocity, and vector. Click each word to learn more about it. These cars raced to the finish. It took both cars 10 seconds to drive their tracks. Which car was traveling faster? Let's find out which one traveled with more speed. The time each car takes to finish only tells part of the story. Look at the tracks. One car had to cover a lot more ground in those 10 seconds. Speed is more than just the amount of time it takes to get somewhere. Let's define some words before we talk about speed. Click the pictures to explore the topic further. A position is a place. Here, the red car looks like it's in first place. Its position is at the front of the other cars. If an object's position changes, we can say it is in motion. If we want to measure motion or speed, we need to have a reference point. This means we must have a place to which we can compare the moving object. This finish line is a great reference point. We can see the car pass the finish line, so we can be sure that the car moved past that point. If we see that an object is in motion, we can measure its speed, or how fast the object moves. To know an object's speed, we must first know the distance it has traveled and the time it took to travel that distance. The reference points help us measure the distance. We calculate speed by dividing distance by time. If you watch the train, it has many different speeds. However, it will only have one average speed. Move the timeline to the 5-second mark. How far did the train travel? 5 meters. So use the speed formula. 5 meters divided by 5 seconds is 1 meter per second. Move the timeline to the 10-second mark. In 5 seconds, we see that the train traveled 15 meters. That's 20 minus the 5 it already traveled. It's 5 seconds later than the last time we measured. So 15 meters divided by 5 seconds is 3 meters per second. The train speed changed. Now move the timeline to the 15th. The train moves from 20 meters to 60 meters. The train traveled 40 meters in those last 5 seconds. Again, divide the distance by the time. 40 meters divided by 5 seconds is 8 meters per second. That's 3 different measures and 3 different speeds. Now move the timeline to the total mark. The average speed is the total distance divided by the total time. 60 meters divided by 15 seconds is 4 meters per second. You might hear people use the words speed and velocity as if they are the same. In science, these two words have different meanings. Click each word to learn the difference. Watch these two trains. They have the same speed, but they are not traveling in the same direction. What their speed calculation does not tell you is the direction in which they are traveling. The scientific term velocity includes both speed and direction. Velocity is a vector. A vector is a measurement that includes a direction. For the velocities of the trains to be equal, the trains would have to be going the same speed and in the same direction. Speed is distance divided by time. Look at the trains. We can measure the distance these two trains traveled and the time they took. These two trains have the same speed. You sometimes see speed represented on graphs like the ones shown here. This is a time-distance graph. You can see that the distance increases as the amount of time increases. Each graph matches the car of the same color. Let's imagine that the cars are at a stoplight and that when the light turns green, the cars will start moving. The graphs show how fast the cars can go after the light changes to green. You want the fastest car, so pick the car with the greatest speed. Click the graph of the correct answer. That's correct. The blue car has the greatest speed after the light turns green. The graph shows you that it traveled more distance than the red and green cars in the same amount of time. This runner covered 400 meters in 80 seconds. What is his average speed? Great job! To find average speed, divide the total distance by the total time. 400 meters divided by 80 seconds is 5 meters per second. The average speed is 5 meters per second. This graph shows the speed of a car as it drives through town. Drag each speed on the right over to the correct segment of the graph. 0 meters per second. Well done! The first segment of the graph shows a speed of 1 meter per second. The second segment of the graph shows a speed of 0 meters per second because the distance did not change. The third segment shows a speed of 2 meters per second. The last segment shows a speed of 10 meters per second. These rats will race through their mazes. How can rat A reach the cheese at the same time as rat B? Type your answer in the space provided. Click OK when you are finished. Rat A will have to travel faster than rat B to reach the cheese at the same time. Look at the lengths of the two mazes. Rat A has a longer maze to travel. Therefore, rat A will have to travel a greater distance in the same amount of time as rat B. A greater distance divided by the same amount of time equals a greater speed. You've learned a lot about motion and speed. Before we finish, let's take a quick look at the main points you covered. An object is in motion when its position changes. You can see that an object is in motion when you compare it to a fixed reference point. An object's speed is equal to the distance it traveled divided by the time it took to travel that distance. The faster an object moves, the more distance it can cover. Velocity and speed are different measurements of motion. Velocity is a vector, which means the object has a speed with a specific